So let's say let n be an even integer. Be an integer. Let's start with that. If n is even, then n squared is even. Don't do this. What I'm about to do is very bad. 2 is an even integer. 2 squared equals 4. 4 is an even integer. Done. Is that valid? Does that work as a demonstration of what we wanted to show? No? Why not? Yeah, we selected one number, and we were asked to do this for all even integers, and we picked one number, and so that's not going to work. So you cannot do a proof of a for all statement, which is what this is. This is about all integers. You cannot do a proof of a statement about all integers by looking at one integer. So this doesn't work. I'm going to cross it out. Let's actually do proof now. So the proof, we start out with saying, let n be an integer, assume n is even. Then, by definition, there exists a t, which is an integer such that n is equal to 2 times t. Now we want to look at n squared. So then n squared is equal to 2 times t squared, which is the same thing as 4 times t squared. I'm sorry, there should be no 2 there. Should just be 4 times t squared. And 4 times t squared is equal to 2 times 2t squared. Since 2t squared is an integer, there exists an integer 2t squared such that n squared is equal to 2 times 2t squared. Thus, n squared is even. And we could write by definition, we probably will this time, as you write for higher level audiences, some of these things kind of fall away. But for now, let's write out everything explicitly. Do you get anywhere? So the theorem that we want to prove is, suppose that, and now we're going to have two things. Suppose m and n are integers. And the claim is if m and n are even, then m plus n is even. So I'd like you to just think about how you would write the proof, and then I will come back and actually write the proof. But it's good for you to start seeing if you can anticipate some of the structures. Okay, so I'm going to write the proof, and I'm going to say, so usually we start by saying, let m and n be integers, and then we could say assume m and n are both even. Now, what does that mean? By definition, this means that there exists a q in the integers such that I'm going to need to plug in my computer real quick. I'll be right back. I'm pulling the table to the... So by definition, this means there exists q and z such that m equals 2 times q, and there exists t in z such that n is equal to 2 times t. Let's look at m plus n. We have m plus n is equal to 2 times q plus 2 times t, which is equal to 2 times q plus t.